Now let us discuss oxyacids of halogens. Halogens mainly form 4 types of oxyacids. It's HOX, HOXO, HOXO2, HOXO3. Like if you are talking about fluorine, chlorine, bromine and iodine, fluorine only forms HOF and none of the other acids. What we need to understand is in this the halogen is in +1, here in this +3, in this +5 and in this +7 oxidation state. Chlorine forms all of these HOCl, HOClO, HOClO2 and HOClO3, which we also call it HClO4. Remember, we can club the oxygens together. Bromine forms, yes, HOBr, but doesn't form this one in the +3 oxidation state, HOBrO2 and HOBrO3. Whereas with iodine, what we know is we can have HOI. It doesn't also forms oxyacid in +3 oxidation state. We have HOiO2, HOiO3. Now you need to know their name. This is called let me write down the name here. General name is hypohalous acid. It's called halous acid. It's called halic acid, and it's called perhalic acid. So this is how they go. So this will be called hypochlorous acid, chlorous acid, chloric acid, perchloric acid. This will be called hypobromous, bromic, perbromic, hypoiodous, iodic, periodic. This is how this is hypofluorous acid. So these are its oxyacids. Now all of these oxyacids are sp3 hybridized, and let us see their structures. It will be like this. Like if you are talking about HOCl, so it's chlorine with 1 OH group and 3 lone pairs, so it doesn't have any shape like this. But when we are talking about HOClO, it is basically is having what? 1 OH group, 1 double bonded oxygen and the 2 lone pairs, so it's called bent shape. When we are talking about HOClO2, so remember it's like Cl with 1 OH and 2 double bonded oxygens like this and our lone pair, so it's pyramidal. And when we are talking about HOClO3, it will be like this with the 1 OH group and 3 double bonded oxygens. So it's completely tetrahedral. So these are the structures of the oxyacids of halogens.